Well, I'll just run down this list of questions I grabbed here. Just kind of support questions that have come in over the last couple weeks. The first one is on wire sizing. The customer wanted to know for a specific feeder, how to set that feeder to be a different material type. And you can do that in our new release with the new option that we've added. So you would go into panel edit to make the change, go to the panel where you want to change the wire size, the wire material actually. And under conductor, we now have the new options. You've got your default option, which is what everything is sizing to by default, but then you can also change this specific conductor to be copper or aluminum. So if you want just the main service to be an aluminum wire, you come here, set this one to be aluminum. It'll size it automatically still based upon the size of that panel, but using the aluminum wire sizing. And then everything else will stay as copper. So it gives us a 1/0 aluminum. If we change this panel size, it's going to give us 250 kc mil aluminum. So still sticking with the aluminum wire, but sizing automatically based upon that panel size. The list of options here is from the wire ampacities customization. So if you go to customization and wire ampacities, the list of options you have there are these options up here. And when you select one of these, it'll show you which wire sizes we're going to use by default. So the copper has all the copper wires selected, the top of the two rows. If we go to the aluminum, you'll see that all of this changes to select the aluminum wires instead. We also have a new copper and aluminum, which is in the new default customization, where you'll get copper for your small wires and aluminum for any of your large ones. And then you can add additional ones here using the new command if you want to. We also had a question how to create a new wire configuration with a different set of wires. The default I always go with is we have by default a 400 amp breaker. We have a single run of 600 kc mil. A lot of people like to use 2 runs rather than a single run because the 600 kc mil gets to be a little bit big to work with. So we can create a new option here just by pressing new. You can also change your default if you want to do that. And then you make your adjustments to have the 2 runs of wire. So I'm going to change the description to say 2 runs. We're going to put in 2 runs of wire. And it's essentially a 200 amp feeder at this point. So I'll just pull the values from here. So it's going to be a 3/0 wire. And then a number 4 and a number 6 ground for the 2 different ground sizes. And you do want to get the impedances right to the X and the R value. This is for a single run, and then we'll do the division if you've got multiple runs. So I can just copy these values directly from the 200 amp feeder. And this wire ampacity, again, also is for a single run of wire. So we'll change that as well. So now we have a 400 amp configuration that's going to use 2 runs. And it's not being used by default. So if I go to my copper, you'll see by default, I'm still using the single run. So if you want to have that as your default, you could check these. And then by default, a 400 amp wire is going to use that 2 runs. So if we go into panel edit again, go to this MDP panel, we now have 4 conductor sizes. We have the 400 and the 400 2 runs, and also the 400 aluminum. So you have those 3 different options of configurations of wire for a 400 amp feeder. In the new release, we have removed the feeder schedule. So if you're looking for the schedule, so that we used to have a feeder schedule listed here, we actually got rid of that, and that was on purpose. The feeder schedule that we displayed, because of the way Revit works, it's just pulling what Revit calls electrical equipment, which is essentially panels and transformers. It was not able to pull electrical fixtures in the same schedule. And then in the one-line diagram, that then caused problems. I don't have it built out here. It would cause problems if you have an actual piece of equipment. It's not going to show the feeder for that equipment, so it wasn't matching up the feeders on your one line with the feeders in that schedule. So we got rid of it, and we have the new one-line diagram feeder schedule instead. So to demonstrate that, let's put in, if we put in this elevator panel, and then I'll put in the elevator itself. And I'll put in one panel that's feeding that. I'll put in the MDP. So if I insert this elevator panel, not the elevator, the actual elevator itself. On the one line, obviously, we'll then draw the feeder, we'll label the feeder. The feeder schedule is not that we used to have wasn't going to show that because this is not electrical equipment, this is an electrical fixture. So instead, we generally recommend you use the new schedule insert in the one line diagram, and this will show you all the feeders that are being used on this one line separate. So it'll just show you it'll label what's being used here. So it's a better correlation. If you really want to use that old feeder schedule we have, you can use it. You could copy it from an existing project if you have any that have it, or you can create it manually. And there are instructions on the website in the knowledge base on how to do that, because it's just a standard Revit schedule. There wasn't anything special we were doing. We were just creating a schedule that had some fields arranged nicely to list an approximation of a feeder schedule. So if you want to, you can always go to schedules and create a new schedule based upon electrical equipment and then put in the columns yourself. And there's instructions for that on the website if you really want that schedule. But no, it's not going to be a complete feeder schedule. And so that's why we chose to remove it. It's rare that we actually remove anything, but that thing was not salvageable and we felt it better to just remove it so it wasn't confusing and people expecting it to do more than it did. So you can get it back using standard Revit, hopefully understanding the limitations of that schedule. The new schedule we have in the one line diagram is more complete. For the one line diagram, there are a couple questions on how to do the customization of it. In options, we have a bunch of choices for what you can do, in particular for the feeder IDs. If you don't want to show these IDs, if you just want to call out the sizes directly, you can turn them off. So if you go from yes to no, that'll remove them from the project. You actually do need to run a calculate after you do that. It's not going to go and make the updates. So if I run the, this is a warning about the feeder schedule that there's no feeder ID, so it's not going to put a schedule in. But when we update the feeder, when we update after removing the IDs, all the IDs are gone.
Kelly had a written comment there.
Yeah, I see that. Kelly, you're asking, so the question is the feeder schedule, if that updates automatically, and the answer to that is yes. It updates definitely when you run the calculate. I don't think it updates when you just change a feeder size, so you do need to run the calculate and then it'll update at that point. So if I go back and I put that back on, calculate again. And when we did that update, it didn't pick up this ID, so you'll notice that it's only listing the IDs that are actually being used. This one isn't being shown, so it's not listing it there. If we go back and put that ID back in, so it's not going to update immediately, but when we run the calculate, it should show up. And it's struggling there also. Let's check one more thing. When you change your customization, for the most part, we try and handle it well. In this case, switching from IDs on to off is not working terribly well. Generally, that's not something you would change in a project. But in this case, it's not pulling that ID in, so I'm just going to redraw the feeder using the feeder reset, and that'll force the ID to come back in. And now when we run the calculate, you'll see it's missing here. We run the calculate, it'll see that new ID is there, and it'll put it in for us. But then if we changed this panel here from a 100 to a 200 amp panel, we do immediately update the one line here and here. We don't update this schedule until you actually run the calculate. So just be aware that's the feeder schedule. It does not update quite as quickly as the other pieces. And the reason for that is that as your one line gets bigger, we have to check the whole one line for pieces, and so it would take a little bit of time. And so it's one of those things that if it did it automatically, your next question would be, how do I turn that automatic update off because it's taking too long? So we just have it off by default. And it gets it when you run the calculate, which you should be doing regularly anyway to get the calculations for all your fault and voltage drop and everything else. When you insert a device, we are pulling this list of one-line diagram graphics here. This list is customizable, so you can add or remove options from there. If I go to a panel, we've got a couple options: panel without bus, which is the default, and a panel with a bus. If you want to have something else as the default, that's essentially just the one that's at the top. And that would be a matter of modifying the list here. You can do that by running customization, the one-line diagram, device graphics. I'm going to run that command. So that opens up this text file. I'm going to resize this so we can see everything. It opens up just in Notepad where it should come in by default. This isn't the fanciest interface, but it's just a text file that you can modify. So if you wanted to have, for example, the panel with bus up at the top, you could just copy, cut these two lines and put them at the top above this panel without the bus. And so now when we insert something, that's going to come at the top, and that'll essentially be your default at that point. If we run insert link, now that graphic is pulling the panel with bus as the default, as the one at top. So we run that command, insert that, and you get the different looking graphic. The final question that I had was, how do you get a transformer primary without a neutral? So Revit is a little bit, getting neutrals right in Revit is tricky. They did not implement neutrals in the way that I would have necessarily implemented neutrals, but we have to work with what Revit gives us. So the way you handle neutrals actually varies depending on whether you're doing distribution equipment or a branch circuit. And just because so essentially a feeder and a branch circuit, you want to handle differently just because Revit handles them a little bit differently. And so we need to have a little better nuance for what's going on there. For branch circuits, you generally want to have home runs. And if you put tick marks on the home runs, it's going to do tick marks based on whether Revit thinks it has a neutral or not. So you need to get the neutral correct for your branch circuits, which is fairly straightforward to do, and I'll show you that in a moment. For feeders, you need to do that differently because the way that the neutrals work for branch circuits, it does it the same way for panels, which actually corresponds to transformers as well. And there are times when it puts a transformer in that you don't. And so you need a different way to say, yes, Revit, I know you think there should be a neutral here, but I really don't want one, so please leave the neutral out. So I'm going to pull up that page on our website. So if you go to help, and if you just go to the Design Master user manual on our website. So in the user manual, down here under advanced topics, we have a neutrals section that explains this because we have to do things a little bit differently than how Revit would maybe totally do it. And even that, no one really understands all of these all the time. So there's two sections, one for distribution equipment, and the distribution equipment is based upon the distribution system. And so you can set up, as you see here in the example, a 480Y with and without a neutral. And so you can specify that as the distribution system, and then that'll control the neutral for your transformer. For branch circuits, you actually define new wiring types and then whether it has a neutral required, and you check that box. If the neutral is not required, Revit will leave it off unless it's an unbalanced load. So if Revit sees an unbalanced load, it's going to put the neutral on no matter what. So the reason this doesn't work is that when you go through a transformer, it's still an unbalanced load in terms of what Revit sees, but you don't need the neutral to the transformer. So Revit's going to put it in there even though you don't want it. And so we basically, for transformers, key off the distribution system rather than the wire types for the neutral. And so that's how we can remove the neutral in an instance where Revit really, really wants there to be a neutral. So if you look at the electrical system for the feeder, Revit's going to list a neutral, but in Design Master we'll actually leave it off because we know in that case you don't want it. So these walk you through the steps for setting it. It's just a matter of getting these configurations right.